Okay, so this is lesson 4, Hess's law, which says we can put together equations like they're kind of puzzles and use that to figure out delta H. But we need to make sure to know how to manipulate them. All right, so this is video problem 4a. So we have b plus 2c going to 2d, and we're given 3 of these equations. Okay? And so the first thing we always have to do is say, hey, if I look at this, b plus 2c, 2d, which ones of these equations have b in them? All right, so if I look at it, equation 1 has b in it. If I look at it, c is only in 2, and d is only in 2. So, looking at this, I can either start with number 1 and try to get b in the right place, start with number 2 to get c in the right place, or start with number 2 to get d in the right place. We can do either one, so let's go with number 1. So I'm going to do number 1, and I want b as a reactant. Notice how on that screen, b is a product. It's on the right-hand side of that arrow, so that means I need to flip it. And I have 1b here, and in that reaction, I also have 1b. So just flipping it will get the right way. So that will get me 2a plus b goes to give me 2e. And my delta H for that, seeing that I flipped it, that's a negative. So that's going to make this negative 182 kilojoules. Okay, so that gets my b in the right place. Let's go on to the c. So I want to use number 2 to get 2c as a reactant. If I look at number 2 right now, it has c as a reactant, so I don't have to flip it, but it only has 1c. I have 2 here, so I need to change it, and I need to multiply it by 2. So I'm going to take number 2 and multiply by 2. That's going to get me 2c plus 2e goes to form 2a plus 2d. Notice everything gets multiplied by 2, not just the c. I need to be very careful with this. If I only do part of it, I'm going to end up and I'm not going to get the right answer. And I'm going to get lost and it'll be annoying. Okay, so I didn't flip it, so it's negative 16, so it remains negative 16. So it's negative 32 kilojoules. Okay, so that's all set. So now all I do is I add these up. And I don't know if I'm done yet, but I'm going to go ahead, add these up, and see what I get. All right, so I'm going to go ahead and just write down all the reactants. Goes to form, and I'm going to write down all the products in red here, 2e plus 2a plus 2d. Here they're all products, here they're products. And if I add these up, this will get me negative 214 kilojoules. Okay, so now looking at 2e, those cross out. 2a, those cross out. So I have b plus 2c goes to form 2d. And that's what I wanted all along. So I'm done. So negative 214 kilojoules is my right answer. Okay? Now, notice I didn't have to use equation 3. Equation 3 is kind of what we can call a red herring, or something that we're not going to use. And, that sometimes happens. Just because we're given information doesn't mean we have to use it. All right, so let's look at this solution one more time. So what do? First, we go ahead and we identify what is only used once, right? So B and C, number 1, number 2, and then I manipulate them to get B in the right spot and then C in the right spot. I don't use C, so I add those up and I get my answer. Notice that the 2A's cancel out. The two E's cancel out along the way. If they didn't, I may have to do a step to eliminate them like we did in class. All right, let's go on to another problem. And give me 1 minute to actually write this up on the board. All right, so it's now up here. Here's the equation I'm looking for, and I'm given these three equations. And so I want to put these together in such a way to get my answer. Now, before I even do this, I'm going to just underline all the reactants. I'm going to do this because, we went over this in 215, and I know there's still some, reactants, products. We need to know what those two are. We need to know that, hey, when something's called a reactant, that means it's what I start with, products are what I end with. That has to be ingrained in our head. Okay, so we want this, and we're given these ones. Oops, this is strontium, not scandium. Okay, so I have this, and I want to go. So first thing I do is, which ones have strontium by itself in there? The only answer is number 1. Equation number 1 has strontium. Here, carbon, it's only in number 2. Oxygen is in 1 and 2. And then strontium carbonate, that's in number 3. So where should I begin? Well, I could begin with equation 1, 2, or 3. Either any of those 3, right? If I do number 1, I'm going to try to get strontium. Number 2, I'll get carbon. 3, I'll try to get strontium carbonate in the right spot. I'm not going to start by trying to get O2 right, because that's not going to work. Okay, so let's do this. Let's start with number 1. We want to get number 1 from 2 strontiums to 1 strontium. Notice they're both reactants, so I'm not going to have to do anything to number 1. I'm not going to have to flip it, but I will have to go from 2 to 1, so I'm going to have it. So that gets me strontium plus half O2 goes to form SrO. Okay. So I have this, so my delta H also halves. So that would be 592 kilojoules. Okay. Oops, negative. Be careful with those negative signs, right? I didn't flip it, so it was negative and still negative. All right, so now I'm going to go ahead and strontium's in the right spot. Carbon. Notice I have carbon here, 1 carbon, and as a reactant, I have 1 carbon as a reactant here. So I don't actually have to do anything to number 2 to get that one right. So I'm just going to copy it down. That's going to give me negative 394 kilojoules. I'm going to add these 2 up. So I get strontium plus carbon plus 3 halves, or 1.5. These are the same thing, O2, goes to form strontium oxide plus CO2. All right, so if I look at, and let's go ahead and do this, add these up. This is negative 986 kilojoules. Okay, so if I look at this, strontium's in the right spot, carbon's in the right spot, oxygen's in the right spot. So we're kind of going, maybe I'm done. But look here, I have SrO and CO2 here. I need strontium carbonate here, SrCO3. All right, so I'm going to take a little pause, come back in a second. Okay, so we're back. All I did was I moved this around a little. So notice I'm pretty good, but the products aren't right. So I've already used equation 1 and 2. If you do this correctly, you should only use each equation once. If you have used them and you're like, I need to use them again, you probably did something wrong. Okay, so let's go ahead and we want to get strontium carbonate as our end product. So right now, I have 1 strontium carbonate as a reactant. I want 1 strontium carbonate as a product. So what do I have to do to number 3? I need to flip it. Right? I need to take it, and I'm going to need to make products, reactants, products. Okay? So I'm going to go ahead and make these reactants, and then this becomes a product. And this is now negative 234 kilojoules. Okay? So now I can underline these, and I'm going to add them up. Okay? I have, sometimes I go ahead and I write this down, but really we should be able to see, hey, here it's a product, here it's a reactant, so these cross out. Here it's a product, here it's a reactant, so it crosses out. So I'm going to be left with let me check. That looks the same. If it isn't the same and you've used everything, you probably did something wrong. Go back, make sure you didn't mess something up, forgot a coefficient, or in this case, remember I start off with this being scandium, SC. Stupid things like that, they do happen. Okay, so I add these up and this gets me negative 12 kilojoules. And that's my answer because this is the same equation as that. All right, let's go ahead and look at this over once again. All right, so the first thing we did was we identified which ones are the right ones to start with. We said strontium is only in number 1, so we said let's start with that. So we took number 1, we multiplied it by half. Then we didn't have to do anything to equation number 2. And then in equation number 3, we had to flip it. Okay, so we're taking each step to try to get a little bit closer to our final problem. Okay, or final equation, I should say. All right, the other part of Hess's law, these ones are all about, hey, putting together equations to get this. The other part of Hess's law is that, hey, we have heats of formation. Remember, heats of formation are the heat to form 1 mole of any compound. Okay? And so we can use heats of formation to figure out delta H for any reaction. How? By summing them up, all the products, and then minus the reactants. And the key is these end terms. That's the number of moles of each according to the coefficient. All right, so let's do a problem. Video problem 4C. We have Cr2O3 plus 3H2 goes to form 2Cr solid plus 3H2O. All right, so we can go ahead and we can just find a delta H for each of these in the back of the book. Right? Appendix number G, I have the link there. So hopefully you already did this problem, looked for those gases, and tried to figure it out. But I'm just going to show those on the screen right now. So if I look there, I have heats of formation for all 4 of these gases. Notice I actually included a few extra, or 1 extra. So the chromium by itself, it's 0. Why? Because this is an element in its free state, in the way it usually is. The same thing for H2 gas. If instead of H2 gas, if this was H2 liquid, it'd have a different heat of formation. I have it also for Cr2O3. And then I have 2 here for H2O. Which one do I use? I use the one that is for a liquid. Okay, make sure you look at the state of the matter too. All right, so I have this up here. Let's do this on the board. So for Cr2O3, we're told it's negative 1,139.7, H2 0, chromium 0, and then H2O liquid is negative 285.53. Okay, so I'm going to use this, but remember the key is it's products minus reactants. So we have to be careful. These are my products, okay, and my reactants are over here. Okay, so it's going to be these minus this. So my delta H will be for the delta HS for my products minus my reactants. Okay, so my products, so first I have chromium, it's 0. So I can do 2 times 0, or just 0, I didn't even have to include that 2, plus 3 times negative 285.53. Be very careful with the signs. That negative is important. I'm going to again subtract off the reactants. I'm going to do this in a little more deliberate way, and I'm going to make sure I'm just going to do the products and then the reactants. That's because it's very easy to make mistakes. Okay? So if I do this, this obviously is 0. So I end up with 3 times this value, which will give me negative 856.59. And then I'm going to subtract off the value I get for my reactants. Okay, so I have 1 chromium oxide, so it's going to be 1 times negative 1139.7. On a problem, do you have to include that 1? No, I'm just including it for thing. In the same way, I don't have to put 2 times 0, I can just say plus 0. Okay. We know, based on grade school, everything that's anything times 0 is 0. Okay, so when I do this, this gets me minus 1139.7. Okay. Minus a minus gets me positive. And that's going to get me a value of 283.11 positive, so I don't even include that, kilojoules. So I circle this, and that's my answer. All right, so that is it for Hess's law. You need to be able to know how to do it with either reactions or with heats of formation. Here again is on the paper, and good luck, and I'll talk to you later. Bye.